Hi all, this video is from the Chapter 11 Exercises to Skills Review at the end of Chapter 11 of our text. I have copied down a series of problems here and I'm going to walk through them one by one. Our goal is to express each of these in reduced form. And I encourage you to pause the video, try the problems that you see on a page, think about how you did, and then watch the video and see if you did them correctly. So now would be a great time to pause the video and try these problems in a distraction-free environment, of course. And then watch the solutions after you've had a chance to try them. All right, I'm going to start with number 2, 7 over 10 minus 2 over 15. We need a common denominator. Now we could multiply this by 15 over 15 and multiply this by 10 over 10, but there's a smaller common denominator of 30 that we could use first. So I'll multiply this by 3 over 3, which of course is 1. I'll multiply this by 2 over 2, which is also 1. And as you know, when we multiply fractions, we multiply through in our numerator, multiply through in our denominator, so that's going to give us 21 over 30 minus 4 over 30, and 21 over 30 minus 4 over 30 is 17 over 30. 17 over 30 cannot be reduced, so that has been expressed in its reduced form. Number 3. Again, we do not have a common denominator, and in this case, the smallest common denominator that we could possibly get would be if I multiplied this left side by 3 over 3, a fancy way again of multiplying by 1. Multiply this right side by 2x over 2x, which is going to give us a common denominator of 6x. Now again, multiply through up top, multiply through down low. 3 over 6x. Take away 4x over 6x. And we've got 3 take away 4x over 6x. Now you might be wondering, can I slash, and we've talked about this a little bit in class, can I reduce that x over x to a 1? And in this case the answer is no, you cannot. Number 5, negative 2 over yz plus 4 over z. And again, we want to find the smallest possible denominator that these two fractions could have in common. So I'll multiply this by y over y, which again is the same as multiplying by 1. Now I have yz and yz in my denominator, and so we can combine these. We get negative 2 plus 4y over yz. And that's should be a z there. Now, you could actually, if you think about it and you wanted to write this, since we've been doing a lot of factoring in class, I could go ahead and factor out a 2 or a negative 2. I'll factor out a negative 2. And when I factor out a negative 2, remember the fastest way to determine what's left over is divide each of these terms by negative 2, and we get positive 1 minus 2y over yz. That would be another way to express our reduced form of this original problem. Number 7, 2 over x squared minus 3 over x. Well, the fastest way to find a common denominator here would be to multiply by x over x, which of course is 1. Now I have a common denominator of x squared. I've got 2 take away 3x over x squared. And that cannot be reduced, and we can't factor anything out of the numerator. I do want to talk about numbers 9 and 10 for a moment with respect to their notation. This, of course, is a fraction bar, and so this is the same as saying 5 over 6 over 15. Now, if you divide, in this case, by 15, then that's the same as multiplying your denominator by 15, not your numerator, and I see an awful lot of confusion on that. Think of 15 as 15 over 1. The denominator then here of 6 we get multiplied by 15. The numerator we get multiplied by 1, which of course is just the identity. And so we're left with 5 over 6 times 15. Now the reason I left this as 6 times 15 is because I want you to consider the fact that we can reduce this more quickly that way, because 5 over 15 is 1 over 3. So in the end we get 1 over 18, which is our reduced fraction for number 9. Number 10, 3 over x squared over 6 is another way that we could express this. Once again, this 6, it gets multiplied, our numerator of 3 gets multiplied by 6, the x gets multiplied by x squared, and we get 18 over x cubed, which is as reduced as we're going to get. All right, we're on another page. Try these problems. I'd encourage you to try them first. So pause the video now, and then watch the solutions after you've had a chance to try them and see how you do. Okay, 3 over x over 6 over x squared. In this case, our numerator gets multiplied by x squared, and our denominator gets multiplied by 6. And so I'm going to rewrite this as 3x squared over 6x. Now 3 over 6 reduces to 1 over 2. And x squared divided by x reduces to x over 1. And so we're left with, in the end, x over 2, which is the same as 1/2 x. So x over 2, again, is the same as 1/2 x. If the x, or the independent variable, is off to the side, that is the same as considering it to be part of our numerator. All right, number 14, number 12. These next few problems are going to include a different skill. So here's what I want you to think about. How do x minus 1 and 2x minus 2 relate? In other words, I guess what I'm asking is, what would I need to do to x minus 1 to make it 2x minus 2? Or what is the least common denominator is probably a better general question. Well, the least common denominator, if you think about it, would actually be 2x minus 2. And if I took x minus 1 and I multiplied it by 2, of course I'm going to have to multiply my numerator by 2 as well to keep the value here the exact same. So multiplying 14 over x minus 1 by 2 over 2 is the same as multiplying it by 1. And now if you were to distribute this 2, you'd get 2x minus 2, which is exactly what we have over here. So we have a common denominator of 2x minus 2. Now in the numerator we have 28 plus 13 over 2 times the quantity x minus 1. You could express it as 2x minus 2 or 2 times the quantity x minus 1. They're the same. And so 28 plus 13 is 41 over 2 times the quantity x minus 1. There's your reduced form. 41 is odd, 2 is even. These do not reduce, but if this numerator had been even, then we could have reduced that as well. And we'll see an example of that later. Number 13, fastest way to find a common denominator. Well, I can see an x squared over here and an x over here. So I'm going to multiply this by x over x. That'll give me my x squared in my denominator. I can see a y to the 4th over here and a y over here. So if I multiply this by y cubed over y cubed, then I'll get a common y to the 4th power there. And so now let's rewrite. We get 4y cubed z over, let's see, y to the 4th x squared minus 3wx over x squared y to the 4th. So we have our common denominator right here, y to the 4th x squared, or x squared y to the 4th. And now we need to combine our numerators. It's going to be 4y cubed z minus 3wx over y to the 4th x squared. And that cannot be reduced. I had to think about that for a second. There's nothing that we could factor out and reduce in that case. All right, number 14. What I want you to notice is in this case we have a y minus 2, and in this case we have a 2 minus y. Okay? The question is, what is the least common denominator? Well, if we were to multiply this, well, actually either fraction, but I'm going to choose to multiply the rightmost fraction by -1 over -1. Okay, again, we're not changing the value of this because you're multiplying it by the same thing in the numerator as you do in the denominator. So you're just multiplying this whole thing by 1. Then what you end up with is 10 over y minus 2 Okay, now think about this for a second. 3 times negative 1 is plus negative 3 over, now we get negative 1 times 2, so I'm distributing this negative 1. That's going to be a negative 2, and negative 1 times negative y is y, so over y minus 2. You have a common denominator of y minus 2 now. Now we can clean this up. 10 plus negative 3 is 7. Common denominator y minus 2. 7 over y minus 2 is our reduced form. Similar problem in number 16, only this time I will just show you that, again, we could in this case multiply the left side by negative 1 over negative 1. That's still going to get us a common denominator, so I'll do that. Negative 8y over, well, distribute my negative 1, and I get 4 minus y, plus 32 over 4 minus y gives us 32 minus 8y over 4 minus y. Now, if you look carefully here, okay, I want you to look carefully at the numerator with me, you can factor out an 8. And if I factor out an 8, then I get 4 minus y in my numerator. And I've got a 4 minus y in my denominator. Now, in this instance, we can reduce because this is 8 is a factor, multiplied by 4 minus y, another factor, divided by 4 minus y, the same factor that shows up in the numerator. And so one factor multiplied by another divided by one that's already shown up, those two can reduce to 1 over 1, and this actually cleans up to 8. It cleans up quite nicely. Okay, next page. If it wouldn't be a bad idea, it wouldn't hurt to pause the video again now, try these problems, and then watch the solutions. I'll give you a hint before you try them. In this case, when you're looking for common denominators, you're going to be, I would encourage you to factor, for example, this first, and then think about what is still needed over here to find that common denominator. So that's your hint. Give them a try. Okay, so this, this right here, okay, factors, let's think about this for just a second. So 3x and x give me my x squared. And if I say plus 1 and minus 4, then I've got my 3x squared. I've got my minus 4. Okay. There's a plus 3x and a minus 4x, which gives me the minus x that I'm looking for. Now, if you look carefully, you have a factor of x plus 1 here, and there's a factor of x plus 1 over here. If I multiply this fraction by the quantity 3x minus 4 over 3x minus 4, then I now have a common denominator. Okay? So, I've got 8, take away 20, take away, I should say 9, I was skipping a step there. Take away 9 times the quantity 3x minus 4, all divided by now a common denominator of, I'm just going to write it in its factored form, so x plus 1 times 3x minus 4. Okay, so again, think about it. Here's my common denominator. I pulled together the 8, that's my 8, and along with the minus 9 multiplied by the quantity 3x minus 4, and I'm in business. I'm going to distribute my negative 9 to both of these terms, and that will give me 8 minus 27x plus 36 over the factored form x plus 1 times the quantity 3x minus 4. I'm running out of room here, bear with me, so I'm going to clean this up, and when I do, I get negative 27x plus 44 over the quantity x plus 1 times the quantity 3x minus 4. Now it's worth considering, can that be factored, or can that be cleaned up? And so you might think about, hey, can I factor anything out of the numerator such that one of those factors would reduce with one of the factors in the denominator? And in this case, it's not possible. So this is in its reduced form. Of course, we could write this as 44 minus 27x over x plus 1 times the quantity 3x minus 4 as well. Number 18, you can see that the denominator is already in factored form, whereas over here we had to do a little bit of factoring first. But what I want you to notice is what's key here is that in this case the x minus 3 is being squared. In this case it's x minus 3 to the first power. In this case it's x plus 5 to the first power, and over here it's x plus 5 quantity squared. So in order to get a common denominator, we have a little bit of work to do. I'm going to multiply the left fraction by the quantity x plus 5 over the quantity x plus 5, which again is just a fancy way of multiplying by 1. And there's my x plus 5 times x plus 5, or the quantity x plus 5 squared. I'll multiply the right fraction by the quantity x minus 3 over the quantity x minus 3. And now there's my x minus 3 quantity squared, which also shows up over here. So I've got a common denominator. Okay. Now, this 15 is going to have to get distributed to both of these terms, plus 7 gets distributed to both of these, and we're going to rewrite our common denominator. So 15 times x is 15x. 15 times 5 is 75, plus 7 times x is 7x, and 7 times negative 3 is minus 21, and this is all over our factored denominator, which is going to now be x minus 3 quantity squared times the quantity x plus 5 quantity squared. I'm going to clean up the numerator. That's a 75, by the way, I believe. And we'll get 22x plus 54 is equal to, divided by, I should say, x minus 3 quantity squared times the quantity x plus 5 quantity squared. You might consider, is it possible that the numerator could be factored? In this case, you could factor out a 2, let's say. But, and so we can go ahead and do that just to show you. So I've got 2 times the quantity 11x plus 27 over the quantity x minus 3 squared times the quantity x plus 5 squared. But that's as clean as it's going to get. In other words, there's no factors in the numerator that reduce with any factors in the denominator. So there's your reduced form. Okay. Number 19 and number 20, I think, are a little bit easier than numbers 17 and 18 were. Similar to some that you saw. Well, I should say, actually not similar to some that you saw before, because these are not opposites. And when I looked at it at first, I thought maybe they were opposites. They're not. Okay, so in this case, let me do a little erasing to give myself some room here. In this case, we need to multiply the right side by the quantity x minus 4 over the quantity x minus 4, and the left side by the quantity x plus 4 over the quantity x plus 4. Keep in mind, again, that's just multiplying by 1. I think it might help, at least it helps me, to remember to wrap these, because, yeah, that's a pair of, it's a quantity there is what I'm trying to say. And now I want to talk about an idea that's going to come up quite a bit as we progress through the course. Big picture, if you have a plus b times a minus b, and you expanded that through foiling, you're always going to get a squared minus ab plus ab minus b squared. But keep in mind that minus ab and plus ab, those cancel. The correct term there is cancel. They equate to 0. And so what you'll always be left with is a squared minus b squared. We'll apply that up here. X minus 4 times x plus 4. X plus 4 times x minus 4. There's a plus b times a minus b. A plus b times a minus b. We should expect to get a denominator in this case of a squared minus b squared. So x squared minus 16. X squared minus 16. Okay? And you're going to see that quite a bit throughout this course, and in future courses such as calculus as well. I'll distribute my 3. I get 3x plus 12 in my numerator. I'm going to distribute a negative 2. I think, again, it helps to circle that as we've been talking about throughout the course. And so make this a plus. Here I'm adding them together, but negative 2x plus 8 is what shows up in our numerator there. So now I've got my denominator of x squared minus 16. 3x plus negative 2x is x. 12 plus 8 is 20. And I've got x plus 20 over the quantity x squared minus 16, which does not reduce. Again, if you wrote this in factored form, if you went the other direction, you'd have x plus the quantity x plus 4 times the quantity x minus 4. All right, number 20 does look similar to a theme that we saw earlier. X minus 1 and 1 minus x are opposites. So again, I could multiply in this case this by, let's see, negative 1 over negative 1, and now I should have a common denominator. You could have done that over here, multiplied the right fraction by negative 1 over negative 1. You would have also had a common denominator. So I've got negative x squared, let's see, over, when I distribute my negative 1, I get minus x plus 1, which is the same as plus 1 minus x, okay? And then it's minus, or the same as a plus negative 1 over 1 minus x. They're the same. Combining the numerators, negative x squared minus 1 over 1 minus x. Okay. Now, interestingly enough here, you could, if you wanted to, I mean, that's one way to express it, which you could, if you wanted to, you could factor out a negative 1. If I factored a negative 1 out of the numerator, okay, and negative 1 out of the denominator, another way to think about it would be x squared plus 1 here, and then we'd end up with an x minus 1. So take a moment and think about that. Negative 1 over negative 1 reduces. So this is one way to express it. But as we've talked about throughout the Chapter 1 algebra skills in particular a few weeks ago, you could also, as long as all of the values are opposite, that is equivalent to factoring a negative 1 out of the numerator and the denominator. And so negative x squared minus 1 over 1 minus x is the same as positive x squared plus 1 over x minus 1. All right, number 22. We have u plus a plus u over u plus a. Now, I'm going to show you something a little bit different here as far as factoring goes. I'll name the concept in just a moment, but before I do, I'm going to multiply this by u plus a over u plus a. I'll multiply this by u plus a over u plus a, which is 1, and this is 1, and so now I have a common denominator of u plus a. So this is now u times u plus a times u plus a plus u all over u plus a. So take a moment and think about that. Okay, so I collected all three of these. They all had a common denominator of u plus a. Collected all three together. There it is. Now, if I have, this is called factoring by grouping. If I have u times u plus a times u plus a, these are both being multiplied by u plus a, then I can call that u plus a times u plus a. Okay, so that takes care of these two pieces right here. Now I still have this plus u to tack on, so I've got a plus u in my numerator. Sorry, changed pages on me there. I've got a plus u in my numerator, and in my denominator, I still have a u plus a. Now, next big idea, u plus a multiplied by itself is u plus a quantity squared. So I'm going to call this u plus a quantity squared plus u over u plus a. There's our reduced form. Okay? All right, I want to look at numbers 25 and then this other problem, which is one that I'm made up, is very similar to 25 and 29, and I've got three things starred here. What I want you to notice is the b squared minus a squared, b squared minus a squared, a squared minus b squared, a squared minus 9. In this case, in all three cases, you have what's called a difference of squares. They're called a difference of squares because you have one number squared, subtract another number squared. One number squared, subtract another number squared. One number squared, subtract another number squared. So a difference of squares. Okay? Now, new here, actually I'm going to start with number 29 for a moment. So when you have a difference of squares, we said before that if you have a minus b times a plus b, you will get in the end a squared minus b squared. And I showed you why. That was on a previous page 5 minutes ago or so. Okay? But let's work our way, think through this, working your way backwards. So if you have a squared minus b squared, you can factor it into the quantity a minus b times the quantity a plus b. Here's your difference of squares that we're talking about. So here I've got a difference of squares, a squared minus 9. I'm going to rewrite this as a plus 3 times the quantity a minus 3. Notice it's 3 and not 9. Okay? When you square 3, you'll get 9. And so I'll rewrite the whole expression as a over the quantity a plus 3 times the quantity a minus 3 plus 1 over a minus 3. And now what I hope you can see is that the common denominator we need is a plus 3 times a minus 3. Well, over here I've already got my a minus 3. I'll multiply this then by a plus 3 over itself. Okay, now I have a common denominator. I'll take my plus 1, I'll distribute it, and I get a plus 3 over, I'll just write it again as a squared minus 9. It's the same. A squared minus 9, again, it's the same as a plus 3 over a minus 3. Of course, this is, instead of a plus a, I'm going to say 2a plus 3 over a squared minus 9. And that is as reduced as we can write it. Let's jump up to 25 and the other problem like 25. I want to point out before I go any further that this is a multiplication symbol, and so is this. So now I'm multiplying fractions. Okay? So a little different. I don't need a common denominator. You require a common denominator when you're adding or subtracting fractions. If I'm multiplying fractions, I'm just going to go ahead and remember I'll multiply through up top and multiply through down low. Okay? And so what I get is a plus b times 8x plus 2 over 2 times, now I'm going to go ahead and factor b squared minus a squared. Okay, I want you to see it. So b squared minus a squared is b minus a times b plus a. There's your difference of squares in factored form. Now, you have a number of quantities here. You've got a quantity here, a quantity here, 2 multiplied by a quantity and multiplied by another quantity. You can do some reducing. So a plus b over a plus b reduces to 1. Of course, here we can factor out a 2. And so I'm going to rewrite this as 2 times the quantity 4x plus 1 over, in this case, 2 times the quantity b minus a. Well, 2 over 2 reduces to 1. So that reduces to 1, and we're left with 4x plus 1 over b minus a. That cannot be reduced any further. This next problem, just an additional problem like number 25, meant to be very similar. You've got a minus b, there's a factor, multiplied by, I'm going to go ahead and just say, okay, keep it as 14x minus 49 for now, over 7 times, I'll say the quantity a minus b times the quantity a, I should say a plus b. Well, a minus b over a minus b reduces to 1. We can factor a 7 out of here, so I'll rewrite. This is going to be 7 times the quantity 2x minus 7. Okay, and I can double check by, if I redistribute it, there's my 14x minus 49, over 7 times the quantity a plus b. 7 over 7 reduces to 1. 7 over 7 reduces to 1. And we're left with 2x minus 7 over a plus b. That, again, cannot be reduced. All right. So we've got this page and one more, and we'll call it a day. But I know there's a lot here. I want you to think about, in this case, the fact that you have a fraction divided by a fraction. I know it's written a little differently than what you're used to seeing. I did this on purpose. I'm going to I won't rewrite it. Let's just do this. Think of this. Numerator, okay, denominator, and then this fraction is in your denominator, and so think about where would this go? Where would this go? So if you have x cubed over x minus 4 over x squared minus 2a minus x. This quantity here is going to get multiplied by that quantity, and these two are going to get multiplied together. So we're left with something like, we're left with this, x cubed times the quantity x squared minus 2x minus 8 over x squared times the quantity x minus 4. Okay, so that would be step 1. Again, we've got a few factors here. That's a factor. Okay, that's a quadratic, which we're going to see if we can factor in just a moment. And then I've got x squared over x minus 4. The first thing I'd like to point out is that x cubed over x squared reduces to just x over 1. And now, if you factor this piece, you're going to get the quantity, well, let's think about it for a second. The quantity x minus 4 times the quantity x plus 2. So double check me there. Okay. Now, we rewrite. We were still left with this x in our numerator. And so I've got x times the quantity x minus 4 times the quantity x plus 2 all over the quantity x minus 4. Okay. X minus 4 over x minus 4 reduces to 1. I'm left with x times the quantity x plus 2. Okay, and we can express this as x times the quantity x plus 2. We could also express it as just x squared plus 2x. Okay, so a couple of different ways to write number 30 there. All right, I'm going to jump to 31. And so for number 31, there's a little extra work to be done here. This will look, you'll see problems like this, algebraic expressions like this in Calculus 1 and Calculus 2, for those of you moving on at the end of the semester. But what I want you to think about first is consider the fact that to combine these two, I need a common denominator. Okay, and then we also are going to need to think about where this h goes. So I'll start by multiplying this by x squared over x squared. Okay, I'll multiply this by x plus h quantity squared over x plus h quantity squared. Now I've got my common denominator up top, and so we've got, think about it, this is a negative 1 times this, so I'll get x squared minus, and I'm just going to say x plus h quantity squared, okay, because minus 1 times x plus h quantity squared is minus x plus h quantity squared, divided by x squared times the quantity x plus h quantity squared divided by h. All right? Now, this h, again, this h becomes part of the denominator, and so I can express this as x squared minus the quantity x plus h quantity squared over x squared h times the quantity x plus h quantity squared. Okay. Now, I want to say very clearly, because I've seen a number of students do this, you don't distribute the negative until after you've expanded the square of the binomial. So expand the square first and then distribute the negative. So let's do that. We've got x squared minus x squared plus 2xh plus h squared. So I skipped a step there. Remember, this piece here is x plus h times x plus h, right? It's the quantity x plus h squared. And when you expand that by that product, you're going to get x squared plus 2xh plus h squared, okay, over x squared h times the quantity x plus h quantity squared. I'll distribute my negative to all three terms, and when I distribute my negative to all three terms, I get x squared minus 2xh minus h squared all over x squared h times the quantity x plus h quantity squared. That's a lot. It's a mouthful. X squared minus x squared reduces to 0. Okay. You could factor an h out of the numerator, and so let's think about that. H times the quantity negative 2x minus h over, and the reason I factored an h out is because we have a factor of an h in the denominator as well. And so now when I reduce this h over h, I'm left with I get 1 over 1 there. And this leaves us finally with an expression of negative 2x, that should say minus h over x squared times the quantity x plus h quantity squared. Okay, there's no more cleaning that we can do there. All right, number 36, and actually this will be the last problem that we look at. I'm not going to do the next page. We can open class next time I see you with some additional problems that I wanted to try. But this next one is, it's challenging. It's a tough problem, and so I'm actually going to do a little bit of erasing here in order to give myself a bit more space to work. Okay. That should be enough. So, a lot going on here. First of all, I need a common denominator between these two. And once I get a common denominator there, I'm going to need a common denominator between this over here and this over here. But let's start over here in the denominator. So I'm going to multiply this by p over p. And I'll multiply this by q over q. So each of those are being multiplied by 1. And so now we get p minus q over p squared over pq plus q squared over pq. We can now add these two together. So let me put an arrow up here. I've now got p minus q over p squared plus q squared over pq. Okay, so let's think about that for just a moment. This is the same as if you think about it. Now the way we have it written, it's the same as saying, I'm trying not to skip steps here. It's the same as saying p minus q over 1 over p squared plus q squared over pq. So now maybe it's more apparent that I'm going to change colors. These two get multiplied and these two get multiplied. And so now I'm going to jump over here. I've got p minus pq squared, okay, because that's going to be this q over here times the pq, so pq squared over p squared plus q squared. All right? Now, the issue is I don't have a common denominator once again. So I'm going to multiply p by p squared plus q squared over p squared plus q squared. So now I do have a common denominator. Let's go this way. That's p cubed. So let's talk about why it's p cubed. Let me change colors. P times p squared is p cubed. P times q squared is going to be, I'll change back to pink, so p cubed plus pq squared. And then I've got a minus pq squared. Okay, all over, looks like p squared plus q squared. Common denominator of p squared plus q squared. Now, we're almost there. Pq squared minus pq squared, the verb there is cancels. They equate to 0. And we're left finally with p cubed, that should say p cubed over p squared plus q squared. And that is your reduced answer. It's not going to clean up any nicer than that. You might be asking yourself, well, and this is a good question, can I reduce p cubed over p squared to just p in my numerator? The answer is no. It doesn't work when you have a monomial, mono 1, over a binomial by 2. You cannot reduce just one. If it was the other way around, if there was a binomial in the numerator and a monomial in the denominator, then you could reduce. But this is as clean as it's going to get. All right, that's all I've got for you. That was a 40-minute video. Thanks for paying close attention. Now go ahead and try the Chapter 11 Skills homework assignment, and I look forward to seeing you in class next week.